Now it's time to move on for another type of another type of algorithm, so which can be used in pattern discovery. So basically, so what we are gonna see now is hierarchical clustering. Hierarchical clustering. So hierarchical clustering is a popular unsupervised machine learning algorithm used to group similar data points into clusters based on their similarity or dissimilarity. Unlike k-means clustering, which requires specifying the number of clusters in advance, hierarchical clustering builds a hierarchy of clusters by iteratively merging or splitting them. So the results is often visualized as a tree-like structure called a dendrogram. Dendrogram. So the result is often as a, visualized as a tree-like structure called a dendrogram. So the main idea behind hierarchical clustering is to find a nested structure of clusters where smaller clusters are nested within a larger clusters. So this approach provides a more detailed and intuitive representation of the relationships between the data points compared to the other clustering algorithms. So this is what is hierarchical clustering, and to define it in much simpler way, hierarchical clustering is a popular method for grouping objects. It creates groups so that objects a group within a group are similar to each other and different from objects in other groups. So clusters are visually represented in a hierarchical tree called a dendrogram, as we have discussed earlier. So hierarchical clustering has a couple of key benefits. One is there is no need to pre-study the number of clusters. Instead, the dendrogram can be cut at the appropriate level to obtain the desired number of clusters. So, second one, data is easily organized, or organized into a hierarchy using dendrograms. So dendrograms make it easy to examine and interpret clusters. So hierarchical clustering can be performed in two main ways. One is agglomerative clustering, and in another way we call it as a bottom up. So an, an agglomerative clustering, it starts with each data point as a separate cluster, merge the closest pairs of clusters iteratively until all data points belong to a single cluster. Then finally, the distances between clusters can be measured using various methods such as complete linkage, single linkage, average linkage, or Watts linkage. So this is what is called agglomerative clustering. So now, and the second way of achieving hierarchical clustering is divisive clustering, or we can call it as a top-down clustering. So divisive or top-down clustering. So again, this starts with all data points in a single cluster, then recursively split the clusters into smaller subclusters until each data point belongs to a separate cluster. Then finally, the final step is then splitting process can be based on various criteria such as maximizing intercluster dissimilarity or minimizing intercluster dissimilarity. Either one can be used, either maximizing intercluster dissimilarity or minimizing intercluster dissimilarity. So this is what is an hierarchical clustering in a nutshell. So to sum it up, in hierarchical clustering, the similarity or dissimilarity between data points is measured using distance metrics such as Euclidean distance, Manhattan distance, or cosine similarity. So these distance metrics quantify the dissimilarity between two data points and play a crucial role play a crucial role in determining which clusters to merge or split. A key advantage of hierarchical clustering is its ability to visualize the clustering process through dendrograms. Very, very important. So, the key or main uh, advantage or benefit of hierarchical clustering is its ability to visualize the clustering process through dendrograms. A dendrogram is a tree-like diagram that illustrates the sequences of merging or splitting clusters and the distances at which these operations occur. So the height at which two clusters merge or split in the dendrogram represents the dissimilarity between them. So hierarchical clustering has application in various domains, including data analysis, biology, social sciences, and most important one, market segmentation. So it allows for the identification of hierarchical relationships within data, can provide insights into the structure and organization of the data set. So overall, hierarchical clustering is a flexible and powerful clustering algorithm that can reveal intricate patterns and structures in data, making it a valuable tool in exploratory data analysis and pattern discovery.